Let's discuss the risks associated with using static credentials instead of employing AWS Assume Role. Static credentials, such as access keys and secret keys, can pose significant security risks if they are compromised. These credentials are often long-lived and, if exposed, can be used to gain unauthorized access to your AWS resources. Another risk is that static credentials are difficult to manage across an organization. If a credential needs to be rotated or revoked, it often requires manual intervention, which can be time-consuming and error-prone. Additionally, static credentials can end up being embedded in your codebases, scripts, or configuration files, increasing the chances of accidental exposure or misuse. This can lead to vulnerabilities if those files are shared or inspected by malicious actors. On the other hand, using AWS Assume Role provides a more secure way to access resources. Roles can be configured with short-lived temporary credentials that automatically expire, reducing the window of opportunity for an attacker. Roles also offer granular access control, making it easier to follow the principle of least privilege. By transitioning from static credentials to roles, you can improve your security posture and better protect your AWS environment from unauthorized access. On this slide, our goal is to outline the key purposes of this section of the course. Firstly, we aim to understand the risks associated with using static credentials on AWS. Static credentials can pose significant security vulnerabilities, which we need to mitigate. Secondly, we'll delve into the advantages of using AWS Assume Role, an approach that offers a more secure and manageable solution for accessing AWS resources. Finally, we will explore practical solutions to enhance AWS security by implementing these practices effectively. In this slide, we will delve into the risks associated with using static credentials in an AWS environment. Firstly, let's talk about the risk of a security breach. Static credentials, such as AWS access keys, can be easily exposed or stolen. One common example of this risk materializing is when code containing these credentials is mistakenly committed to a public Git repository. This kind of exposure can lead to unauthorized access to your AWS resources. Secondly, static credentials have the drawback of being long-lived. They do not expire on their own, which significantly increases the window of opportunity for misuse by malicious actors. This long-lived nature can make managing security quite challenging. Next, there is the issue of complex management. Ensuring that static credentials are regularly rotated and securely distributed can be quite labor-intensive and error-prone. This complexity often leads to inadequate security practices that leave your systems vulnerable. Lastly, static credentials offer limited auditability. Tracking and auditing the usage of static credentials is challenging, making it difficult to detect and respond to unauthorized access. Understanding these risks is crucial in enhancing the security posture of your AWS environment. Let's delve into a real-world scenario that highlights the risks we've discussed regarding static credentials. In this particular incident, an AWS access key was unintentionally exposed in a public GitHub repository. Because of this oversight, unauthorized individuals were able to gain access to AWS resources. The fallout from this event could be severe, including potential data breaches and significant financial losses. This example underscores the dangers posed by using static credentials, reinforcing the need for better security practices. Now that we've looked at a real-world scenario where static credentials were exposed, let's dive into the advantages of using AWS Assume Role. Firstly, Assume Role provides temporary credentials. These credentials are automatically rotated, reducing the risk of credentials being exposed for an extended period. Secondly, you can enforce the principle of least privilege. This means you assign only the minimum required privileges to IAM roles using IAM policies, making your AWS environment more secure. Enhanced security is another significant benefit. Since the credentials are temporary, the risk associated with the exposure of long-duration static credentials is substantially reduced. Finally, it simplifies credential management. There's no longer a need to manually manage and rotate long-term credentials, making your security management both easier and more efficient. These advantages make AWS Assume Role a powerful tool in securing your AWS environment. Implementing AWS Assume Role is an essential part of leveraging AWS's security capabilities. On this slide, we have a step-by-step guide for creating an IAM role, which will allow you to assume the role and gain temporary credentials securely. Here's how to implement it. Step 1. Creating an IAM role. 1. Navigate to the IAM console. Start by going to the AWS Management Console, navigate through Services, then to IAM, and proceed to Roles. Click on Create Role. 2. Select Trusted Entity. You need to define which AWS service will be trusted to assume the role. For example, if you're setting this up for an EC2 instance, you would select the EC2 service. 3. Attach Policy. Next, you attach a policy to your role. You can either choose a predefined policy from AWS or create a custom policy tailored to your specific needs. 4. Review and create. Finally, review all the details, provide a name for your role, and create it. Implementing these steps correctly ensures that you adhere to the principles of least privilege, enhancing your security posture by minimizing the risk associated with long-term credentials. In this slide, we're demonstrating an example of creating an IAM role using the AWS CLI. The command shown here is AWS IAM create role, which is used to create a new role named my role. The -assume role-policy document parameter specifies the trust policy JSON file that defines which AWS services can assume this role. In our example, the file is named trustpolicy.json. The JSON content within the trust policy allows EC2 instances identified by service ec2.amazons.com to assume the role. The action specified, STS assume role, permits the EC2 service to utilize the role. This way, EC2 instances will have temporary access to the permissions defined in the role once it is properly attached. This is essential for tasks such as allowing instances to interact with other AWS services securely. Now that we have successfully created our IAM role, the next step involves assigning this role to an EC2 instance. To do this, navigate to the EC2 dashboard in the AWS Management Console. Select the specific EC2 instance you want to attach the role to. Click on Actions, then Instance Settings, and choose Attach Replace IAM Role. You will then be able to select your previously created IAM role from a drop-down list. This way, your selected EC2 instance will have the permissions defined by the IAM role. Let's proceed with these steps to ensure our instance can assume the role and access the necessary AWS services securely. Once your IAM role has been assigned to the EC2 instance, it's crucial to verify that the role has been correctly attached and is functioning as expected. To do this, we can use a couple of curl commands directly on the EC2 instance. Firstly, you need to obtain a token to access the instance metadata service. This is done with the following command, token curl x .tp.254.254 latest /API token hx EC2 metadata TDL seconds 21/1600. This command requests a token valid for 6 hours, 21,600 seconds from the instance metadata service. Next, use the retrieve token to call the instance metadata endpoint and verify the IAM role credentials attached to your instance. Curl h x.ic2 metadata token NASL 169.254.1254's latest metadata /security-credentials /. This command queries the metadata service for the IAM role security credentials on your EC2 instance. If your role is correctly attached, you will see the name of your IAM role and some associated credentials information. This step is essential to ensure that your instance has the proper permissions and can perform the designated tasks. It helps in confirming that the IAM role is active and correctly assigned to facilitate secure and authorized access. Now that we've verified the role in the previous step, let's focus on some best practices for managing IAM roles effectively. First, always apply the principle of least privilege. Grant only the permissions that are essential for the role to perform its tasks. Next, segmentation is key. Use different roles for different tasks to minimize the risk and scope of a potential breach. Monitoring and auditing are also crucial components. Enable AWS CloudTrail to keep a detailed record of all role assumptions and activities. This will help you track any unauthorized attempts or anomalies. Lastly, implement and manage security policies to govern the usage of these roles. Create fine-grained policies and ensure they're regularly reviewed and updated for compliance with your security requirements. These steps will help you manage your IAM roles securely and effectively. On this slide, we focus on critical questions you should consider regarding the security of your credentials. First, how often do you rotate your static credentials? Regular rotation of static credentials is crucial to maintaining security and minimizing the risk of unauthorized access. Next, check if any of your credentials are exposed in public repositories. Exposed credentials can be a major vulnerability and could potentially lead to unauthorized access and data breaches. Lastly, think about the impact a breach using static credentials could have on your organization. Identifying potential risks and consequences will help prioritize security measures and ensure you're adequately protected. By reflecting on these questions, you can better understand your current security posture and identify areas for improvement to safeguard your AWS environment. In conclusion, static credentials present significant security risks due to their potential exposure and misuse. AWS Assume Role provides a robust alternative, offering enhanced security and easier management of credentials. To effectively mitigate the risks associated with static credentials, it is essential to implement best practices. Key points to take away include understanding the dangers posed by static credentials and recognizing the benefits of AWS Assume Role. Moreover, adopting best practices will further safeguard your environment. As next steps, it's crucial to review and update your existing credential management approach. Transition to using AWS IAM roles wherever possible, and ensure you continuously monitor and audit your AWS environment for any security anomalies. For further information and guidance on the topics we've covered, here are some valuable references to dive into. First, explore the AWS IAM best practices. These guidelines will help reinforce secure access management in your AWS environment. Next, delve into the AWS security documentation to deepen your understanding of the various security measures and tools available. Finally, familiarize yourself with the AWS CloudTrail documentation for insights on how to effectively monitor and audit your AWS activities. These references are essential resources to help you maintain and improve the security of your AWS infrastructure. Thank you for tuning in. I hope you found the content informative and valuable. If you enjoyed it, please leave a like and comment below with any thoughts or questions you may have. Also, don't forget to subscribe to the channel for more updates and share this course with your friends and colleagues. Your support helps us continue to provide quality content.